Assalamu alaikum, my dear students. How are you? Hope you will be fine and okay. I welcome you all into my today class. Our today topic is interaction of radiation with matter. So let us start with the name of Allah Almighty. Bismillah ar-Rahman ar-Rahim. In our today topic, we will discuss the interaction of alpha particle with matter, the interaction of the beta particle with matter, and the interaction of gamma rays with matter. The first, uh, the first topic is the interaction of alpha particle with matter. Now, as I already told you in the previous lecture, that we have the problem of the reduced syllabus, right? And that is some of the most important topic are being skipped, and I think that a simple introduction to those topic are necessary, and time and again I do that. But here I will tell you that as far as the nuclear radiations concerns, the nuclear radiation, as you know that in class 10th you have studied that we have the three types of nuclear radiation: the alpha, the beta, and the gamma. Now, as far as the alpha and the beta are concerned, alpha and beta, they are particles, massive, they are particles. While for the gamma, you know that gamma are actually rays, right? And they are chargeless and massless. Chargeless and massless particles they are. Chargeless and massless. Now, how they interact with the matter and what is the result, this is the most important point here. But I would like to recall you some of the properties of the alpha particle, because we are discussing the interaction of the alpha particle with matter. So the few important point here are, it is, you know, alpha particle are helium nuclei. This is what you have learned in class 10. They carry a charge of +2. E means twice the charge on electron. Mass, you know that 4 times the mass of the hydrogen. 4 times mass is what? Mass is 4 times that of the hydrogen atom. And you already know that they travel 1/100 the speed of light. They travel 1/100 with the speed of light, and they have greater ionizing power because of the double charge, greater ionizing greater ionizing power, and less penetrating power, and they have less penetrating power, right? So you see that, as I told maybe earlier or in the class 10, that those radiation which have greater ionizing power, they have always less penetrating power, and those with less ionizing power will have a greater penetrating power. Why? The reason is very simple, that during ionization they lose energy, and they cannot travel through a much greater distance inside the medium. And now you also know that alpha consists of 2 proton and 2 neutron, as I told, they are helium nuclei. So for the beta, I will discuss when I explain the interaction of the beta particle. So let us start with the interaction of the alpha particle with matter. Now, for the interaction, the first most important point is the range. the range of the nuclear radiation in the medium. Now, what we actually mean the range? It is the distance traveled by the particle, the distance, it is the distance traveled, it is the distance traveled by the particle, the distance traveled by the particle in a medium, in a medium, the distance traveled by the particle in a medium, the distance traveled by the particle in a medium before coming to stop, before coming, before coming to stop. That is called the range of the the range of the particle inside the medium. Now, the medium, what could be the medium? The medium, the medium can be solid, can be liquid, or can be gases. Even they can be concrete also. They are the medium. Now, the question is that the what are the factors that affect the range of the particle in the mediums? Factors affecting the range, affecting the range. This is the most important one. Factors that is affecting the range. Those factors are two. The first factor which describe the range is the charge, mass, and energy of the radiation. The energy of the radiation. So these are the properties of, in fact, particles, properties of radiation. So it not just alone one factors, properties of radiation. So it depends on all these factors. Second, it depends on the property of the medium also. Depends on the property, depends on the property of the medium also, of the medium also. It depends on what? It depends on the property of the medium also. So let's see, for example, what the properties of that medium. The property of the medium is like density and ionization potential. Density, density and the ionization potential. Density and the ionization, density and the ionization potential. Density and the ionization potential of the medium, right? So these are the few factors on which it depends. Clear? Now let me talk about how, for example, the charge. So you know that if the charges, for example, if you compare the charge of alpha particle and the beta particle, so alpha particle have twice the charge is that on the beta particle. So there will be a greater ionizing power then, right? So for example, alpha particle will what? That if I talk about the alpha particle, then it will quickly ionize. Similarly, mass, if the mass is greater, then the incoming radiation will be deflected less, right? Their path will not be disrupted because of its heavy mass. And second, the energy. So as far as the energy is concerned, the excitation and the ionization energy of the particle. So this is why these are extremely important. So if you just see here in this diagram, look, the three kind of nuclear radiation here, the alpha, the beta, and the gamma. So for the alpha, as you see, that the alpha can be stopped even by mm, a banknote, you may say a small piece of the paper, it cannot pass through. What is the reason? Because as I already told that it carries a charge of plus 2e, twice the charge on electron. So it quickly ionizes the given the atoms in the given substances. And what they actually do, that I would like to write here for the alpha particle, that alpha particle during their interaction with matter, alpha particle, alpha particles during the interaction of the alpha particle with matters, alpha particles capture, alpha particle captures two electrons, two electrons and become helium nucleus and becomes and alpha particle capture two electrons and becomes helium nucleus. Sorry, not nucleus, and become helium atom, right? So that is the way in which the alpha particle interact. Alpha particle are the most dangerous one because of its ionizing power, that it has greater ionizing power and less penetrating power. So it can cause burn and sore when fall on the human body. So thanks God that its penetrating power is low, and even it can be stopped by wearing gloves. So this is how the alpha particle interact with the alpha particle interact with the alpha particle interact with the matter. The next is the interaction of the interaction of the interaction of beta particles, the interaction of beta particles with matter, the interaction of beta particles with matter, the interaction of beta particles with matter. Now you see, look, first let me tell you what are beta particles. Beta particles are the stream of fast moving electrons, fast moving electrons, fast, so fast that they travel 1/10th the speed of light. Their speed is 1/10 the speed of light. They are so fast. And there are two set of beta particles, the beta negative, that is electrons, and you also know that the beta plus, and we call them positron. And you already aware of the fact of the positron, that they have the same mass but opposite charge, and you already know they can easily be deflected by the electromagnetic field. So whenever the beta particle, upon interaction with matter, upon interaction with matter interaction with matter upon interaction with matter, the beta particle, they decelerates and produces X-rays and produce X-rays. Bremsstrahlung radiation, right? If you remember the production of the X-rays as I told. So here you see the alpha particle. Look at the alpha particle. The alpha particle, the beta particle, less mass, right? That is the less charge, so their ionizing power is small and penetrating power is greater. And remember one thing which I want to add, they cause ionization by Coulomb repulsion. Causes what? Causes the ionization. The ionization, because they cannot attract electron, causes the ionization by repulsion, by Coulomb repulsion. So they also ionize the matter. But inside the matter, when they're being slowed down, then you see Bremsstrahlung radiation. So Bremsstrahlung radiation mean X-rays. So when they decelerate inside the medium, they lose their energy, slows down, and produce X-rays, right? So just like the opposite of the photoelectric effect. Okay, so this is the interaction of the beta particle inside the beta particle, the interaction of the beta particle inside the matter. The third one is the third one is the interaction of what? The interaction of gamma rays. Why gamma rays? Because I told that gamma rays are chargeless and massless particle. And massless particle usually, as I already told, they are energy packets. Energy packets for us. And they are nothing but X-rays. They are what? They are X-rays of extremely short wavelength. Extremely short wavelength are very high frequency, The frequency is so high, very high frequency, that they cannot be deflected by EM field, electromagnetic field, and they travel so fast that they travel what? 100% with the speed of what? With the speed of light. It is means that its speed is equal to c, that is the speed of light, 3 into 10 to the power 8 meter per second, or 1 lakh 86 miles 86,000 mile per second, or 300,000 kilometer per second. So they travel with the speed of light and has very very weak ionizing ionizing power, but very high penetrating power, but very high or extremely high penetrating power. Penetrating power, their penetrating power is very high. Now here look, see in this case the gamma rays radiation, very high energy electromagnetic radiation. Here you see now, look, they can pass through paper, metal, concrete, as you see, lead you see here. So they are so energetic that 25 centimeter thick piece of lead can reduce the intensity to half. The intensity to half. So I think if you want to block it, so to block this 50 centimeter thickness would be much appropriate for them. They can even pass through concrete, as you see here. Now look, they cause scattering inside, and when they interact with the matter, then they can lead to the process of pair production. Pair production. They can cause what? The pair production. That is the transformation of energy into mass upon interaction with the matter. Now, the interaction of the gamma rays, uh, I will discuss this in two ways. The interaction of the gamma ray with matter. With matter. This is what I will explain the basis of 2 points. Here you see one interaction, that is with air. In the medium is air. This medium is the stuff through which the radiation can travel. What is medium? Medium. The stuff through which radiation can travel or pass. Through which radiation can travel or pass. And the other one is that is with solids. So we will explain this. If, let's suppose, for example, that is for the gamma rays, if I choose I naught is the original intensity. The original intensity of the gamma ray, right? That is when it originates, and it is the intensity right at the time when it leaves the nucleus, and I is the intensity, the reduced intensity. The reduced intensity, yeah, the intensity they dropped after entering into what? After entering into the medium. So here, that in case with air, upon interaction with the air, it obey inverse square law. Obey inverse square law. What does this mean? It's obey inverse square law. That if you double the distance, right, in the air, then the intensity of the gamma rays reduced by 4 times, right? And upon, if you increase the distance 3 times, 9 times, the intensity of the gamma ray will reduce. But the story is different here. In the case that is, it obey exponential. The process is what? It is exponential process here. It is exponential here. It is an exponential here. It does not like that. For example, if you have a metal piece, like for example, let me choose this one. No, this does not seem good. Let me try it. Okay, let's choose red. Like this. If this is any a thick lead, for example. So as you see, when the radiation enters, then here is a different story, like this one upon enter. So the process is what? The process here is exponential process, right? That is the process is what? The process is almost exponential. It decay exponentially, right? That is the range is decreasing. Oh my God, what I did. When it enters, like this one, slows down like this. So their slowing down is exponential, It is what? Exponential maximum, and then gradually decrease like this, but never fall to zero, right? And this can be done. This is the range. That range is denoted by X, like this. And this can be calculated, the reduced intensity, by the expression or formula mu naught into X. Now, whereas this, as I told, the reduced intensity, this is the original intensity. This is called the coefficient of absorption, right? Depends on the nature of the medium. Depends on the nature of the medium. While X indicates range of the particle, or range of the radiation, that through which distance or how much distance it travel. The negative sign indicates the negative sign indicates that intensity reduces. That intensity reduces, but exponentially. It's a mathematical function. Even you can calculate it like this. For example, like this I naught, you can calculate the range by this way also, and taking the length. So I naught, and this will be minus mu naught X. And if you just see, log your X will be equal minus the length I naught into mu naught. So this indicate that the intensity decreases. So this is how the gamma ray interact with the gamma ray interact with the matter. The interaction of the gamma rays is again of three type, as I already wrote here. Look, the low energy interaction. So the low energy interaction, when the energy of the gamma ray photon is less than 0.5 MeV, 0.5 MeV, million electron volt. Such effect, such interaction results photoelectric effect. That results what? That results the photoelectric effect. That low energy interaction what? Reduces when the gamma ray photon has energy less than 0.5 MeV, then the result is what? Resulting photoelectric effect. Resulting photoelectric effect. Photoelectric effect. Right? And then the high energy interaction, the later on that I will come to the intermediate, I'm leaving it deliberately. The high energy interaction, when the energy of the photon is greater than 1.02 MeV, then such kind of interaction results what? Pair production. Pair production. That is the transformation of matter into the transformation of energy into matter. And if you remember, particle, antiparticle, electron, positron pair will be produced. Intermediate energy interaction, when the energy of the photon is less than 1.02 MeV and greater than 0.5 MeV. This is what? Here, the result is what? Result, what is the result here? Results what? The Compton effect, Compton scattering, Compton effect, right? That is the intermediate energy interaction. It will results the Compton effect. So this is how the interaction of the energy take place with the matter. I'm sorry, there was one important point in my mind I forgot. to tell you about the intermediate energy interaction. So in the intermediate energy interaction, there is simply here that it is what, let me, I just got, this is X-ray photon. What? X-ray photon. This is ordinary light photon. Light, both invisible and visible light photon. And that is a gamma ray photon. So every photon is photon. Right? So that is the interaction of this. Now, the next one is the interaction of neutron. Interaction of the interaction of neutron with matter. With matter. One thing which I want to tell you, neutron being chargeless particle, being what? Being chargeless particle, being chargeless particle does not produce any, does not produce any ionization, reduced any ionization, right? That is that it is it, that the neutron is chargeless, though it has mass is that of the proton, but for the nucleus it is easy to capture. Why? Because it does not carry any charge. This is why it is best for what? Best for producing, best for producing secondary emission. Secondary emission means it is not radioactive by itself, but cause radioactivity. Can cause what? Can cause or make other radioactive. This is why I call it that it can produce secondary kind of radioactivity. It makes non-radioactive radioactive. For example, when nitrogen is bombarded with an alpha particle, right? So that is why it causes secondary emission. Even it is also dangerous. For example, the eyes are the most sensitive part to the nutrients, right? That the eyes can get more damage when the nutrients falls on it. Okay, so that is the interaction of the nutrient with what? With matter. So we usually use nutrient for what? To the nutrient to cause secondary emission. Beside this, it can cause fission also. For example, when uranium 235 and uranium 235 and uranium 235 92. So when you expose uranium 235 to the nitro nutrient, slow moving nutrient, there is a greater probability of splitting this nucleus, causing fission reaction. Sorry. So this is our today lecture. Thank you very much for being here. So this is all about the interaction of radiation with matter. So inshallah, see you in the next lecture.